Okay, some key terminology here. Displacement over an interval is just how far did you go? S sub b minus S sub a, with S being the distance. Average velocity is slope. Velocity at a particular time is the derivative. Speed is the absolute value of velocity. Distance traveled is the sum of the absolute values of the distances between turning points. All right, we'll talk more about that later. Direction changes where velocity changes from either to positive to negative or negative to positive. Velocity does not need to pass through zero or even be defined at the point where the sign changes in order for the direction to change. That's great. All right, example 7. We've got a rocket. Model rocket is launched vertically, and we have an equation for its position. Find the velocity and the speed of the rocket. All right, so here we go. I think I'll use this one. All right, so the velocity then is going to be the derivative of position. All right, and in this case, that would be negative 32t plus 114. Okay, and it says find the velocity and the speed of the rocket when at t equals 2. All right, so v of, 5. V of 5 would be negative 32 times 5 plus 114. Okay, and so negative 32 times 5 plus 114 is negative 46. So this is negative 46. And this is in feet per second. So feet per second. Okay, but the speed is the absolute value of that. The absolute value of velocity. And in this particular case would be 46 feet per second. All right, is the rocket speeding up or slowing down at t equals 5? Well, we know then that the velocity is negative. We just now need to find out about the acceleration. So the acceleration is the derivative of velocity. And in this case, is negative also. So negative 32 feet per second squared. Feet per second per second. All right. And so let's type. So since velocity and acceleration are both negative when t equals 5, the rocket is speeding up. Something like that. Okay. All right. Now, next is what is the maximum height the rocket will rise? All right. Well, the maximum is going to happen whenever your derivative is equal to 0. All right. So what I need to do then is I need to, because that'll be the moment where the slope of the tangent line is equal to 0. Before that, it'll be positive. After that, it'll be negative. All right. So let's find that moment. So I need to know when is v of t equal to 0? When is that velocity equal to 0? Okay, and so well, that's going to happen when negative 32t plus 114 is equal to 0. And if we solve that, I've got 144 divided by 32, 4.5. So that 4.5 seconds. So this is t equals 4.5 seconds. However, that is the when, not the what. And so the what would be s of 4.5. Which is going to be negative 16 times 4.5 squared plus 114 times 4.5. All right, and so that's negative 16 times 4.5 squared plus 114 times 4.5, and that's 189 feet. Okay. Okay, so then the next thing then is we want to know what is the speed of the rocket when it hits the ground. Well, if that was a fresh question, you know, I would take the I would try to find out when s of t is equal to 0. But because of what we know about symmetry and parabolas, then we know that that's going to be when t equals 0 and 9. So it's going to take it 9 seconds for it to come back and hit the ground. Well, and I also know the velocity, but the speed is going to be the absolute value of the velocity. So this speed that we're talking about will be the absolute value of velocity when t is equal to 9. All right, so it's the absolute value of, and velocity was negative 32 times 9 plus 144. And then absolute value, again, my graphing calculator on the computer is gone. I've got to get that back. So negative 32 times 9 plus 144 is negative 144, for real? Okay. So this is going to be the absolute value of negative 144. Which is going to be 144 feet per second. And there we go. All right, so that is all for example 7.